Hello and welcome to Nunley Math. I am your host, Aaron Nunley. I appreciate you joining us here today as we wrap up our discussion of inequalities with a look at how inequalities and absolute value problems can appear together, or what it looks like to have absolute value bars in an inequality. This is our final lesson for inequalities. So I hope you'll join us next time as we talk about functions and what a function is and what it means to be a function. Very, very excited to begin that lesson. So I hope you'll come back and join us for that. But for today, I want to talk to you about inequalities. If I asked you to graph all the solutions to the absolute value of x is less than or equal to 3 on a number line, and there's our number line, it's important for us to think about what an absolute value bar tells us. You'll remember from our discussion earlier in the year that an absolute value means the distance without regard for the direction. And if we think of absolute value bars that way, we can actually think of the inequality we have as this. The absolute value of x is less than or equal to 3 means give all values that are 3 spaces from 0 or less. Remember, this is saying the distance from 0 is less than or equal to 3 spaces. Well, before we try and graph that, let's just think about some numbers that are less than 3 spaces away from 0. 1 is only 1 space from 0. 2 is 2 spaces from 0, and 3 is exactly 3 spaces from 0. But those are not the only numbers that are fewer than 3 spaces from 0. A negative 1 is only 1 space away from 0. It does go in the negative direction or to the left on our number line, but remember absolute value says ignore the direction, just focus on the distance. Same thing for negative 2, same thing for negative 3. Negative 3 is exactly 3 spaces away from 0. And also don't forget that 0 is less than 3 spaces away from itself. It is exactly in the same position as itself. And of course, there are some fractional or decimal values that are in between. So if I were trying to show all solutions to the inequality, the absolute value of x is less than or equal to 3, this is what I would need to show. I want you to think about what it would look like if you tried to describe that relationship without using absolute value bars. Those types of pictures did come up in our last discussion where we talked about compound inequalities, and in fact we can describe this using a compound inequality. In fact, if I were to graph all those values that are greater than or equal to negative 3, and I were to graph all those values that are less than or equal to positive 3, you will notice that the overlap of those two sets of solutions matches the solution to our absolute value inequality. In fact, when we talk about absolute value inequalities, we can always express those using either a conjunction or a disjunction, like we talked about in the last set of problems. Or in our last video. You'll remember that a conjunction says, let's just focus on where our two sets of solutions overlap, like this case. A disjunction says, take all the solutions from the first inequality and all the solutions from the second inequality and combine those into one solution set. Since we're just looking at the overlap here, can you describe this as a compound inequality or as a conjunction? Hopefully, you've thought of this. X is both greater than or equal to negative 3, that's this purple line, and x is less than or equal to positive 3. Remember, the things out here on the right and on the left are those values that work in one of the inequalities, but this section in the middle here is the overlap, or the union, or the intersection, or the things they have in common. Now, we could also describe this using our between language by saying x is between negative 3 and 3 as well. Remember, This is an example of a conjunction because the solution includes all the numbers that are greater than -3 and also less than 3. They're the solutions between -3 and 3. What I need us to realize today is that whenever you have an absolute value inequality, where your absolute value is less than or equal to a number, you're always thinking about some central point, and you're looking at things that are close to that central point. In this case, less than 3 spaces away. Since we're looking for things that are close to that central point, we're always going to be finding the intersection or the overlap of two inequalities. Okay, we're always going to be looking for the intersection overlap anytime we have less than. That's whether it's just less than or equal to. That gives us our rule. When solving inequalities involving absolute values, such as the absolute value of A is less than B, we're going to solve two inequalities, and we're going to connect them with the word and to make them a conjunction. Let's take a look at the absolute value of 3x is less than 15. Here's how we're going to solve that. We're going to take it and we're going to split it into two inequalities. One of those is going to use negative 3x. The other one is going to use positive 3x. A couple ways to think about that is this. If I'm going to use absolute value bars, when I have something inside, if that number is a positive number, the absolute values are going to keep it positive. If what's inside is a negative number, the absolute value bars are going to take that negative number and make it positive as well. Essentially, what that means is that this and this, once you take the absolute value of them, should end up being the same thing. Let's go ahead and solve these. To get rid of a times -3, I'm going to divide both sides by -3. To get rid of a times +3, I'm going to divide both sides by +3. When I do that, remember that dividing by a negative sign is going to cause your inequality symbol to flip and become, instead of less than, a greater than. Notice that 15 divided by -3 is -5. Same thing over here. When I divide both sides by 3, I'm left with x. Since I divided by a positive, the sign does not flip, and you get 15 divided by 3 is a 5. I can graph x is less than 5. I can graph x is greater than -5. And when I do that, I have an overlap. This section in the middle is my solution. Notice that all of these things are within 5 spaces from 0. 5 spaces from 0. Notice if I were to pick a number like 3. 3 times 3 is 9. Absolute value of 9 is less than 15. Notice if I were to pick a -3. 3 times -3 is -9. The absolute value bars will make it into +9, which is less than 15. As long as my x value is smaller than 5, I know that this is going to end up being smaller than 15. Same thing over here. As long as my value is greater than -5, like a -4, -3, I know that when I take the absolute value of it, it will be less than 15. Also, I am aware these ought to be open circles. That is a little bit of a typo, so you can correct those as well. Notice, of course, also that we can use our between language when we go to graph this. Here are some procedures that we sometimes give for people to solve absolute value inequalities. For the first of our two inequalities, I'm going to suggest that we reverse the inequality and use the opposite of B. Reverse the inequality and use the opposite of B. For the second, we're going to use the inequality that's given, and then we're going to use and in between the inequalities. Let's try another one. 4x is less than or equal to 28. I'm going to split this in two. One of them is going to be 4x is greater than negative 28. Notice I reversed the sign and I made it a negative 28. The other is going to be as written without the absolute value signs. And of course, we want the and in the middle. In the previous example, I actually would have written this as negative 4x is less than or equal to 28. And then when I divided both sides by the negative sign, or by the negative 4, then I would have flipped the sign. A lot of times we find it easier just to go ahead and write it as the reverse of the symbol and the opposite of the number. In either case, when you go to solve this, you're going to divide by 4, and you get x is either greater than negative 7, and you get x is less than or equal to positive 7. The graph on that says x is greater than negative 7, once again forgetting my equal sign. X is less than positive 7. We look for the overlap, and we have a solution here. This, of course, needs to be colored in. And there you go. Notice as well, I did list this using the between language. And there's a relisting of the rules. You might want to take a second and try this one on your own. I'd recommend pausing the video, trying that, and then watching the video. Once again, I'm going to split this. Notice, instead of having to rewrite this as positive 4x minus 2 on the right and then putting a negative sign out here and then dividing both sides by a negative, I went ahead and took that less than, reversed it, and made it greater than a negative 10. And then over here, I just wrote it as written without the absolute value signs. I'm going to hurry through the solving because our video today is going to be just a little on the long side. And you ought to be good at solving these by now anyway. Feel free to pause the video at any point you think you're having difficulty. I end up with x is greater than negative 2 and x is less than 3. Or you can write that using the between language. On my number line, x is less than 3, x is greater than negative 2. We're looking just at the overlap. And our solution is here. If you pick any number in this set of values and plug it in, you will get something that is less than 10. One extra thing I need to make sure that I point out that's very, very important is just like when we were solving absolute value equations, it is extremely important that you get the absolute value expression by itself before you split the problem, which means we're going to need to add 2 to both sides. From there, it splits and is solved just like the others. Here again, I'd recommend pausing the video, trying this on your own. I am going to work through it relatively quickly. Notice that this does have that typo there. And here's your solution. Once again, you can write it with the between language. When we go to graph this on the number line, you get things that are less than or equal to 9.5. You get things that are greater than or equal to negative 2.5. Looking for the overlap, this is your set of solutions. Here's one last one I really want to make sure we spend some time looking at. Notice if I split this, I get 5x is greater than 35. Notice I flipped the sign and I used the opposite. And then I did it as written. When I solve those, I end up with x is less than 7 and x is greater than 7 and x is less than negative 7. Or this one's a little tricky to write with between language. Notice when I go to graph it, greater than 7, less than negative 7. Do you notice anything weird here? There is no overlap. There's no overlap. This has no solutions. Now, could we have predicted that without going to all this trouble? Hopefully you realize that if you have an absolute value, it can never be less than a negative number. That came up in our equations unit as well, where we had absolute value problems that had no solutions. It was something where it was equal to a negative. Remember, we can't be less than a negative number because absolute values will always come out as positives. Absolute values cannot be less than a negative, so this has no solutions. Make sure when you do something like that that you go back and you erase the things on your number line where you were showing your work, because those would look like solutions to the person who was grading your paper. Here's one. This one is slightly different because we're looking at things that are greater than or equal to 5, greater than or equal to 5. Remember, absolute value means distance without regard to direction, so we're looking for numbers that are 5 spaces from 0 or more. That would be things like 5, 6, 7, 8, 9, 10, and so on. Or negative 5, that's 5 spaces away from 0. Negative 6, negative 7, negative 8, negative 9, and of course negative 10 as well. Keep in mind that this set of solutions can be described as x is greater than positive 5. This set of solutions can be described as x is less than negative 5. This is an example of a disjunction. A disjunction, because since there is no overlap, we would describe these points as all of these answers combined with all of these answers. Remember before, when we were trying to narrow things down to the middle, we had that overlap and we were just looking for that middle section. When we're talking about things that are far away from 0, we're not looking at something here in the middle, we're looking for things that are way out here on the end. Those should not overlap, and therefore you will have to do this using OR, which is a disjunction. A disjunction. This is our formal rule. When we're solving the absolute value of A is greater than B, we normally would do A is less than negative B, or A is greater than positive B. We'll talk about that again here in just a second. If I give you the absolute value of 3x minus 8 is greater than or equal to 5, and I ask you to graph that on the number line, we're actually going to do this in almost the exact same way we did the conjunctions. We're going to split it in two. One of those is going to be 3x minus 8. The other is going to be the opposite of 3x minus 8. Remember, when you put those in the absolute value bars, both those should give you the same solution. Most mathematicians aren't going to show that step. Most mathematicians are going to jump straight to this. They're going to write the one on the right exactly as given, just without the absolute value bars. But the one on the left, they're going to use the opposite symbol and the opposite of what it equals. After this example, I will almost always show it using this method. Instead of putting the negative at the beginning, I'm just going to give you the opposite and the opposite. That really is the difficult part. From here, it's just solving like any other inequality. And when you're done, you get x is less than or equal to 1, or x is greater than or equal to 4 1/3. You can see I did a lot of cutting and pasting to make these slides, and when I do that, sometimes I have a tendency to miss the corrections, but I will make those corrections after we finished recording the video. This is an OR statement. If I'm looking at my graph, here are things that are less than or equal to 1, and here are the things that are greater than or equal to 4 1/3. Once again, I'll make that correction here in just a little bit. Notice, of course, the closed circles. Notice that all of this is a set of solutions that will work here. If I'm looking for things that are farther from 0 than 5 is, I'm going to want things that are way out on the ends, not things that are overlapping in the middle. Once again, reverse the inequality and use the opposite of B. For the second, use the inequality that is given. I believe this is the last example that I have. Once again, we're going to split this in two. Notice this time I skipped the step where we had the negative over here on the left. Instead, I just reversed the symbol, reversed the number. Same thing over here on the right. It's as given to us. And we can solve this pretty quickly. Notice you get x is less than or equal to negative 10, and x is greater than or equal to 6. Both of which graph very easily on the number line. Hopefully you found that to be not overly complex. I don't think there's anything in there that's terribly difficult. I do apologize for the typos. I will get those corrected. But the big thing to keep in mind is just that when you've got greater than, it's always a disjunction. When you've got less than, it's always a conjunction. Make sure for the left you reverse the sign and use the opposite of the number that's given. For the right, use it as written. You remember those things, these aren't too terribly bad. Thank you once again for joining us. I hope this has been helpful to you. If you did find something in there that was useful, make sure you leave a comment in the comment section. Make sure you like and subscribe and turn on your notifications so that you don't miss any of the Algebra 1 that we cover. Best of luck to all of you. Have a great day. Take care.